Okay, so the recording has begun. This is day 3, week 6 of our journey together. Day 3, week 6 of our journey. And it's definitely a delight to have each and every one of you here. Yesterday we covered a lot, and I'd say we covered the major portion of we covered the major portion of probability yesterday, and that is the probability definition. I think that's the most important thing that we did in probability so far, was defining that, or providing that definition of probability. We said that if we have a probability model for equally likely outcomes, it's going to be the following. And the probability model, this works only when the outcomes are equally likely. What that means is that all of the outcomes have the probability or the chance or the likelihood of each outcome happening or occurring, or each event happening. Well, the likelihood of each outcome or of each outcome occurring is equal. So the likelihood or the chance of each outcome occurring in the sample space is equal. That means it is just as likely for us to get a head as it is to get a tail. There's no reason for us to think that heads is more likely than tails. And if there is a reason, then that means that one is not more likely. That means that we are not dealing with equally likely outcomes. But if we are dealing with outcomes that are equally likely, this probability definition holds. And the definition says that we're going to take the number of favorable events, that is denoted as NE, to the number of elements in my event divided by the number of elements in my sample space. Once I divide that, then I will get the probability of the event. Right? And we look at different examples. We look at when we have rolling a fair dice, where we, where the event is an even number. We looked at selecting numbers from the word jasmine, and looking at the probability that we get a vowel. And we looked at the experiment where we have to choose randomly numbers from 1 to 10, and you have to choose a multiple of 5. And those were some of the examples that we looked at on yesterday. Okay, hopefully yesterday you all were clear with what we discussed yesterday, hopefully. And today we're going to continue in the same vein. We're going to continue looking at this definition of probability, teasing it out and weaving it out and looking at the things therein. All right, so let's continue. I'm going to slower. I'm going to make this smaller. So let's push this on the side as usual. I definitely want to keep our participants on this side and push this over. I still have to send the video for yesterday to those persons who did not receive it. So please bear with me. Hopefully I can send it in short order. So please bear with me for the video for yesterday. All right, so let's continue with these questions. So we're just going to do some more exercises looking at, the probability definition. Okay, so this is today is Wednesday. Wednesday the 10th of August. Wednesday the 10th of August. Some of you probably are already buying school uniform. Anyone already start buying school uniform yet? Or it's too early to buy a school uniform? Hello? Can you hear me?
Yes, sir.
Okay. Anyone start buying school uniform yet? Or trying on new school uniform, shoes, whatever, shirt?
No, sir.
No? Okay, I guess it's too early. Okay.
Really? Yeah.
Too early? Oh, Caitlin, you said yes? Okay. All right. Which shoes you want? Or it doesn't matter? I guess Caitlin didn't guess that question. But I know a lot of people, they like Clarks. And the typical belt is LAN belt. And the typical shirt is, people like the cotton shirt. And at least that was back in my day. I don't know if that's still the trend. But back in my day, it was Nike bike, LAN belt, and Clarks. That's typically the style. Um, yeah, and if you didn't get the Clarks or the LAN belt, people just feel inferior. But if you don't get that, don't feel bad. Compensate for it in your grades. So make sure, because some of the same students who get all these expensive clothes or be decked up, they still are not performing. And so um, school is not a fashion show. So it is a place where you learn. But it's good that y'all are going back into the classroom though. Oh my, it's been a while. So it's good that y'all can finally get back in to the classroom. That's good. The topic is we're gonna look at probably the definition applied. Okay. Definition applied. Probability definition applied. All right. So we're going to continue in those examples. Remember, the definition is that number of favorable outcomes divided by the total number of the total number of elements that are in the sample space. So that's the definition that we're going to be using. So number of elements in the sample space, or number of favorable um, number of favorable outcomes divided by number of outcomes in the sample space. Okay. Okay. So let's look at some examples or exercises really. We call them problem sets, right? Let's continue with our problem sets. One thing about probability, it's a bunch of, things that we can pull out from different sample spaces that we could use. And so that's the nice thing, or some might say that's the dreaded thing. But probability depends on your perspective. The one sample space that we haven't done, like really done, that I believe that we need to do in a good way is that we haven't really done the standard deck, right? So that's a sample space that we have to look at. And hopefully we can get to look at that today. The standard deck. Okay. When I say the standard deck, I mean the standard deck of cards. Now, for those persons who are familiar with playing card games, you would know what is in the standard deck of cards automatically. But for those of us who don't know, we have to go over it. How many cards are in a standard deck? Does anyone know? Typically, how many cards are in a standard deck? That's an open question. How many cards are in the stand? Say it again.
50.
50? No, not 50. Close though. How many cards in the standard deck? Excuse me. Deshaun, do you know? How many cards in the standard deck of cards? No. How about you, Sierra?
52.
52. Very good. 52 cards are in the standard deck. Alright, so that's a sample space that we need to look at. Remember, it's 52 cards. And so, if that ever comes up, please remember that. Alright, it's 52 cards in the standard deck. Okay, so, let's go. So the problem set here, it says that a class contains let me not keep this bolded, or keep it in bold. Let's underline this. Please take down these notes, and what we're gonna do is take them down, and then right after class send me the class notes. All right, some of you have been very faithful in sending the class notes, and that's great. Others, please pick up the pace on that. So a class contains 15 boys and 9 girls. If the class votes for one pupil to be the class president, or to be the class captain really, and all of them stand an equal chance of election, what is the probability that the elected captain will be a boy, and B, a girl. Alright, so we have a class that contains 15 boys, 15 girls. If the class votes for one pupil to be class captain, and all of them stand an equal chance of election, what's the probability that the class captain will be a boy? What's the probability that the class captain will be a girl? Alright? Alright, so well, first let's begin with the number of elements that are in the sample space. So I think that's a good place to start. So the number of elements that are in the sample space, Deja, is going to be what? Well, no, wait, no, my apologies. Let's start off with let's start off with the probability definition. So first of all, let's describe the event first. So the event is what? That we choose a boy, or we'd say a boy is elected as captain. Or yeah, elected as captain. That's the event. That a boy is elected as captain. And that's the event E, that a boy is elected as captain. All right, Now we know that the definition of probability, or the formula for probability, is that we're gonna have probability probability of an event E is gonna be equal to, hello Jasmine, are you here?
Yes,
Jasmine,
sir.
okay, don't leave right away, okay? I need to talk with you before you go, okay? Don't leave right away. So the number of elements in the event divided by the number of elements in their sample space. Okay, good. So Deja, what's gonna be the number of elements that is in my sample space?
24.
24. How did you get 24?
I add the number of boys and the number of girls together.
Very good. So 15 plus 20, 15 plus 9. That's going to give us the total number of students, right? That are there. Okay. Sienna, what's the number of elements? What's the number of outcomes in my event?
Sienna stepped out.
Okay. Caitlin, answer for me, please.
15.
15. Okay, very good. So why you say 15?
Because there are 15 boys.
Very good. There are 15 boys. Very good. Excellent. Okay, so 15 boys. And so if we put it all together, it's going to be equal to 15 divided by 24. Good. Now, can we simplify this, Sierra? Can we simplify this fraction?
Yes, sir.
Okay, so what
By
number is it?
3.
By 3. And what will be the numerator if we use 3?
Okay, so that'll be 5 over 8.
5 over 8. Yes, that's true. 5 over 8. Ah, ha, ha, ha. Look at this. Calculus, right? dy over dx. All right. So it's 5 over 8. Okay, so that's how we do that one. So the probability that a boy is selected as captain is going to be 5 over 8. All right. Remember, for this one, we divide by 3. And so let me show that in my working to make it clear that, hey, we did divide by 3. Okay, did that work? Any questions on this? Yes or no? No or yes? I see y'all so quiet today. I don't know what happened today. Everybody's so quiet. Any questions?
No.
No? Okay. All right. Good. So 15 divided by 3 is 5, and 24 divided by 3 is 8. Go ahead.
So every number we have to divide it by 3?
No, not always. It depends. So here, 3 goes into both numbers. So because 3 goes into 15 and 3 goes into 24, that's why we use 3, right? But say, for example, if we had something like 6 over 36, okay? What number we would use here? You could use 6. So we divide the top and the bottom by 6. Sorry, that's supposed to be divide. We divide the top and the bottom by 6. And then this is going to be 1 over 6. All right. Sorry, let me erase that. That looks so bad. Clear out drawing. So I'm saying if we add 6 over 36, to simplify this fraction, we'd use 6. 6 divided by 6 on top. And 36 divided by 6 at the bottom. And then it will simplify to 1 over 6. All right. So it depends on what numbers we have, right? That's what tells us where we have to simplify. All right, so you have to be careful, look at what you have. You don't always have to use 3. It depends on the numbers that we are given. And sometimes you might be fortunate that, you know, you don't have to simplify at all. So the probability of us getting a boy elected as captain is 5 over 8. Beautiful math right there. So for B, the event, right, E, is that a girl is selected as captain. This is interesting class because there are more boys than girls. Usually there are more girls than boys in a class. Even if we use our class, there are how much girls in there? 1, 2, 3, 4, 5, 6, 7, 8 girls. And how much boys? We have 1, 2, 3, 4. So 8 girls to 4 boys. So yeah, there's usually more girls than boys. So I don't understand this class. Yeah, there are more boys than girls. So it's an interesting class. A girl is elected as captain. But sometimes that could happen. Sometimes that could happen. That could happen. It happened before. A girl is elected as captain. So we want the probability that a girl is elected as captain. So the probability of the event is going to be the number of elements in my sample space divided by, sorry, number of elements in my event divided by the number of elements in my sample space. Sierra, what's how much elements in my sample space?
24.
24. How did you get 24?
15 plus 9.
Good. Why is it 15 plus 9?
Because it's 15 boys and 9 girls.
Very good. And what would be the number of elements in my event?
9.
9. Because there are 9 girls. Right? So since there are 9 girls here, it's gonna be 9 over 24. So 9 over 24. Okay. And we could simplify this. Miss Johnson, what number we could use to simplify 9 and 24?
3.
3, very good. What is 9 divided by 3?
3.
3, very good. And 24 divided by 3?
8.
8, very good. So it's 3 over 8. So we use 3 again because 3 is most convenient for us. And so, in fact, 3 is the highest common factor in this case. You can't use no other number. That is a bet. There's no other factor of 9 and 24 that is higher than 3. So you have 3 over 8. Okay. And so the probability of us getting a boy selected as captain is 5/8. And the probability of a girl being selected as captain is 3/8. So it's going to be what you want divided by the total. That's basically how we do it. All right. Okay, so let's move on to another problem set. Hopefully there's no questions with this one. Also, I just said we should just go into another exercise. It's the same problem set. Okay, so number 2. Okay, so let's say a farmer has 40 white sheep and 32 black sheep. If they, we're talking about the sheep, if they are rounded up in any order, so rounded up, if they are rounded up in any order, for sharing, what is the probability now when we say sharing, we're talking about, when they cutting off the wool from the sheep. So basically giving them a shave, essentially, cutting off their wool to use it to make beds and stuff like that. So what is the probability that the first sheep, or that the first, sorry, to be shared? Like I say, when we say shared, we're not talking about cutting pieces, but shared in terms of, like, their hair is cut off. In this case, their wool what is the probability that the first to be shared is a white sheep or B, a black sheep? So what's the probability that the first to be shared is a black sheep, it's a white sheep, and or a black sheep? All right, so Deshaun, what is my event for the first one?
A white sheep.
A white sheep is what? Is the what? First to be what?
First
First to be what?
shed.
Yeah, first to be shared. So white sheep is the first to be shared. Now the probability definition or formula tells us that it's going to be probability of that event is going to be equal to the number of elements in the samples in the event divided by the number of elements in the sample space. So Jasmine, walk me through this. What's going to be my top number? What's going to be my bottom number? Jasmine Low. What's going to be my top number? What's going to be my bottom number?
The top,
Yeah, the top.
40.
40, very good, because there are 40 white sheep, very good. And the bottom is what?
Then 40 plus 32.
Very good, 40 plus 32. And what is 40 plus 32?
72.
72, very good. That's going to be equal to 40 divided by 72. So let me put this on the side. So the number of elements in my event is 40 because my event is a white sheep is the first to be shared. The number of elements in my sample space is 40 plus 32, which is going to be 72 because that's the total amount of sheep that I have in all. Go ahead, Albernique. Go ahead, Albernique. You have a question?
What do you mean if I can answer the question?
Say it again. I see your hand raised, so I was trying to figure out. You have your hand raised. You have a question?
I was asking if I could tell you how to.
Or you want to answer? You want to answer question B?
Okay, yes, sir.
Okay. All right. No problem. No problem. Okay. So can we simplify 40 over 72? Caitlin, help me simplify 40 over 72. What could we use? Go ahead, Caitlin. What could we use to divide 70 over 42? I mean, 40 over 72.
8.
You want to use 8? Yeah, 8 is perfect. If we use 8, what will be our denominator? Our numerator. Go ahead, Caitlin. If we use 8, what's going to be our numerator?
5.
5, very good. What's going to be our denominator?
9.
9, very good. So it's 5 over 9. Okay, so we divide by 8. Very good choice to divide by 8. Perfect choice. Okay. So in this case, we divided by 8 to simplify it. So that goes to show that you don't have to always use 3. Okay. It could be another number. All right. You're just trying to find the highest common factor. All right. So Albernic, a black sheep. What's the probability of getting a black sheep?
May answer the probability event.
Yes. Wait, let's start with the event. So what's the event?
The event is black sheep is first to be shared.
Yeah, the event is black sheep is first to be shared. Very good. Let me correct this. Move that. Move that. Okay. The black sheep is the first to be shared. The probability of an event is going to be equal to the probability of that event is going to be equal to the number of elements in the sample space with the number of elements in the event on top. So what is our numerator for this one? Albanique,
The numerator is 32.
32. What's our denominator?
40 plus 32.
40 plus 32, which is what?
72.
72. So altogether it's going to be 32 divided by what?
Divided by 72. 30 divided by 72.
72. Very good. Okay. What number we could use to simplify this?
8.
8. Very good. And what is 72 divided by 8?
72 divided by 8 is 9.
Is 9. Okay, very good. And what is what is 32 divided by 8?
32 divided by 8 is 4.
Very good. Excellent, Albanique. Excellent. So it's going to be it's going to be 4 over 9. All right? And that's our answer. So the probability of the event that a black sheep is the first to be shared is going to be 4 over 9. But the probability that a white sheep is the first to be shared is going to be 5 over 9. So it's 4 over 9. Alright, so let's look at another problem set. And this one, I think it will do well to introduce a sample space that you know what, let's continue. Before we introduce that sample space, let's ease our way into that. Because I really want us to look at the standard deck, so we can ease our way into it. Alright, so let's look at another question. So a class of so let me scroll down. This should be what, the third one or the second one? I think the third one. So the third one, the third example says that a class you know what? Yeah, let's do it together. A class of A class of 30 boys contains 18 with dark hair, 8 with blonde hair. Sorry, that's supposed to be 8 with blonde hair, 18 with dark hair, 8 with blonde hair, and 4 with red hair. If the class proceeds to the assembly hall in random order, so randomly, what is the probability that the first to enter the hall has A, dark hair, skip several lines, B, blonde hair, and C, red hair. Okay. So we're going to begin with the event. Okay, so Dylan, help me with this. What is my event? Say it again. What's my event?
Uh, 18 boys with dark hair.
I just want the event in words. So the event would
Oh,
be, yeah,
my bad.
go ahead. The event would be a boy with what?
Dark hair.
Dark hair. Is the first to enter the assembly hall. Okay, that should be good. All right, Jasmine, what's going to be my probability of the event? Jasmine,
Okay. 30.
30 at the top or at the bottom?
The top.
30 at the top? Why is it 30 at the top? Think about it.
Because.
Uh-huh.
Wait, no. No. 30 plus 18?
No. Remember, at the bottom, we're going to be all the boys in the class. All right. So how much boys in the class?
30 boys in the class.
Good. 30 boys in the class. So that'll be at the bottom. How much of dark hair?
18.
18. So where 18 is gonna go?
At the top?
At the top. Very good. So 8 is gonna be 18 over 30. Okay, that's how we do it. Sienna, are you there?
Yes, sir.
Okay, what number we could use to simplify 18 and 30?
3.
Excuse me, there's something higher than 3.
6.
6, yes, we could use 6. So when we divide 18 by 6, what do we get?
3.
3. And when we divide 30 by 6, what do we get?
5.
5. Very good. So it's 3 over 5. Excellent. So the probability of this event, the event that a boy with dark hair is the first to enter the assembly hall, is 3 over 5. All right. Okay, so let's look at another one. B, blonde hair. Miss Johnson, walk me through this. What is gonna be my event? Hello, Miss Johnson, are you there?
Event E.
Mm-hmm.
A boy with blonde hair is the first to enter the assembly hall.
Very good. So a boy with blonde hair is the first to enter assembly hall. What is gonna be my probability?
Um,
So what's my top number? What's my bottom number?
8 is the top number. 30 is the bottom number.
Very good. And how can I simplify 8 over 30?
By 2.
Use 2, okay. 8 divided by 2 is what?
4.
4. And 30 divided by 2 is what?
15.
15. Right, thank you. So this one is 4 over 15. Okay, now we have the event of this one. Sierra, can you walk me through C? It's my event.
Okay, so your event is a boy with red hair is first to enter the assembly hall.
Very good. A boy with red hair. Sorry. A boy with red hair is the first to enter the assembly hall. What's gonna be my probability of my event?
Okay, so it'll be 4 over 30.
4 over 30. Okay. Why 4?
Because there are only 4 boys with red hair in the class.
Very good. Do you have red hair?
Mm.
That's probably the other egg. Okay, what is 4 over 30? Can we simplify that?
Like 2,
You can use 2, and what did it give you?
that'll be 2 over 15.
2 over 15, very good. Okay, very good. So this is how we do it. So this is the formula for probability applied. If you understand this, and if you really understand it, then you've understood in part what you need to understand for any probability question that you are going to see. Now there's still some other rules. No, I know you're gonna I know you're gonna ask that. That's why I just about to say I just gotta say there are some probability questions that you need to learn some extended things to it. And that's why we're gonna need stuff like the addition rule, which we're gonna go to. It's what, 7 o'clock? We could see if we have enough time for that. And then the multiplication rule. Those 2 rules is what we're gonna need for the trees. Okay. All right. So we come into your trees. Deja, we come into your trees. Ah. Okay, so let's actually do some let's transition over to the slideshow, and let me give you all I'm gonna give you all one to try in your own because this one is loaded. When I say loaded, it's just a long question, so it don't make no sense giving you all more than one because this one is a lot in itself. So not hard, just long. So I'm only gonna give you one exercise. So this one is to try on your own. Try it yourself, see how well you are able to answer these questions. So a note paper manufacturer makes pads. And you see, and the thing, right? Like look at our questions. Like we gone from like seriously look at the questions that we're looking at, right? So we going from talking about choosing numbers at random from 1 to 10, looking at letters, choosing letters randomly from the word jasmine, rolling a fair die, right? Today we looked at the probability of selecting people from a class and the probability of a person having dark hair, blonde hair, red hair, black sheep, white sheep with a farmer, and selecting someone as a captain. Hopefully you get to see like there is so much ways we can frame the question for probability, right? That goes to show you the probability is truly applied math, right? It is math applied. Like we could use it, we see in farming, we could use it in dice, we could use it in so much different areas, and we could frame the question in so much different ways. And so that's the good or maybe the bad in probability. That it's not one way we could ask the question. It could be in with different scenarios. So stay put for probability, right? Probability is just one of those subjects where you have to really think and apply your mind. So a notepaper manufacturer makes pads in 4 colors. So what are these 4 colors? Obviously blue. Who doesn't like blue? Blue, white, reminds me of H.U. Nash uniform, baby blue and white, pink, and green. Obviously green is for the great A.F. Hadley. Alright, in a pack of 36, there are always 12 blue pads, 10 white pads, 8 pink pads, and 6 green pads. If I open a new pack, what is the probability that the pad is A, blue, B, white, C, pink, and D, green? So a notepaper manufacturer makes pads in 4 colors, blue, white, pink, and green. In a pack of 36, there are always 12 blue pads, 10 white pads, 8 pink pads, and 6 green pads. If I open a new pack, what is the probability that the pad is blue, white, and green, right? So that's the exercise. I'm going to give you 2 minutes to do that. Or maybe I should give you 3 because it's a long write. So I think 2 is enough. And so we'll keep that timer there. Once the timer is completed, then that's time. So all the best with that.
Caitlin said 2 over. She said 2/6. 12/36.
I thought 12 going to 12 once.
She said she did divided by 6. Ten over 36. Uh, 8 can be simplified by 2, and it would be 5 over. Sorry, 5 over 18. 36 divided by 2 is 18.
Put 8. 10. 10.
8 over 36. 2 over 9. 4.
8. 8. Excuse me, Isaac, I have to ask you a question. Okay, so for pink, I did do divided by two and I get 4/18, and I put equal to 2/9. Okay. Okay. Did you ask me for a question? Okay, so I divided it by 3 and I got 6 over 36 goes to be equal to 2 over 12 and then equal to 1 over 6. 1 over 6. One over 6. I got a 4 to 4.
Waterfall.
I'm not finished yet. I'm literally not finished yet. Mm, just, I don't know, a couple minutes more. I write very slow, I'm sorry.
Okay, I kind of lost, but I think it'll be 4. All is a program, so it'll be 4 to 4.
I'm not sure, but I've got 3 out of 4. Well, it says there's a probability that you will receive a program. And the last channel is not tuned. So you wouldn't get any channel. So that only leaves you 3.
Okay, that'll be 2 to 4. Half.
1/3.
No, Mr. GL, so I lost something, man. Yeah, like I get the part, but A and B, like say what?
That's it.
2 coins are tossed simultaneously. Uh, Heads and tails. Well, 2 heads, 2 tails. So, 2 tails and 1 head, 1 tail. That's 6. Um, oh,
What about tails, heads?
that's 3.
Uh, tails come first, whereas heads and tails, the heads come first. So I don't know. Okay.
3. 1 over 3. And that could be 1 over 3 as well.
I think Caitlin went somewhere. I'm not sure.
One over three, I guess. Because I don't really get how you say that you shouldn't put tails and heads. I mean, I understand it says simultaneously, but even if you throw it up, or I don't get it, but okay. So yeah. I feel like you still get a tail and a head. Still lost to be honest, but okay, we say so.
I lost you.
I'm still lost, honestly. Like you're saying okay, since we have they toss at the same time, there's no difference. So if there's no difference, how come we even have the sample space to begin with? I don't even get it. There's no difference in the parents, I guess. What I don't understand is if we can't tell the difference if we toss in points, then how we see which whether it's head or tail in the first place. I mean, I sort of get it, but I still lost. Okay, I get like you're saying, okay, basically you don't have it numbered, so you don't say this one, the first one is this and the second. Okay, I get that, but I still don't get why we couldn't do it. But I get that. Wait, I have a question. So what you're saying is like how when we have distinguishable, like if you're talking about coins or if you're talking about dice, you'll be like, okay, the second dice fell on six, but the first dice fell on one. But if you have indistinguishable, then you just be like, you got a one and you got a six. Wow.
So for the last, for all I will say that two leg is only do two times and head is the same, so do be one and then three. I ask it like so if it was like head, tail, stays, head, and tails, that would be three. And like only because head, lands twice and the same thing it'd be one. Because like if it lands two times it'll still be the same thing.
Common, according, and conjunction.
And, but, or yet,
Or
nor,
so.
so, for,
Make you make alone. Sammy.
Let me go.
I can tell.
All right, sorry, but all right. So, hello. Okay, can you hear me? Can you all hear me? Am I audible? Okay, I guess. All right. Hello, can you all hear me?
Yes, sir.
All right, good. Okay, so yeah, so the roller coaster had 6 loops. It was the wildest one Mark had ever ridden. Dylan, excuse me, how can we combine this one? We have to use, they say we want to use a comma and conjunction for this one. So what conjunction will we use? All right, I'm not hearing from Dylan. Deja, what we can do?
We can use and.
We could use on. We could use a lot of ones. We could say the roller coaster had 6 loops.
So you can do so too.
So yeah. And so 4.
What?
Not body really. Yeah, that could work. It depends on the context. Yeah, yeah. Let's use the most natural one though. So the roller coaster had 6 loops, and it was the wildest one Mark had ever ridden. So comma and the coordinating conjunction right there. All right, number 2. This is my favorite amusement park. The rides are really exciting. Someone have a comment? Sure. The rides are really exciting. So in order to combine them, we'd say, obviously we could put it in red. Yeah. And we can say, so what we want to use for this one, we want to use, they tell us to use a semicolon, okay, to combine them. So we say, this is my favorite amusement park, semicolon. The rides are really exciting. Right, so there we use the semicolon to combine these 2 clauses. And the third one is, we can say, Altonique wanted to ride the roller coaster 7 times the lines were too long. So I could use a comma and conjunction for this one. Which comma and which conjunction should I use, Sierra, for the third one?
Okay, but by the lines.
Yeah, very good. So you can say Altonique wanted to ride the roller coaster 7 times, comma, but the lines were too long. All right, so that's important. Number 4, we can say Lynette was determined to ride the carousel again. She waited in line. All right, so we want to combine it with a comma and conjunction. So what conjunction should we use, Sierra?
But again.
No.
Oh. Okay, on.
Not on.
Then that was determined to ride the carousel again, and she waited in line.
Okay.
Comma then and then she waited in line.
On ain't the bad one. On is not the best one. Lynette was determined to ride the carousel again. So she waited in line. All right. So as a consequence of a determination, right? Because she wanted, right, to ride it again. So therefore she waited in line. Number 5. The amusement park had a whole variety of rides. All of us found something we enjoyed. Here we want to use a semicolon. And for this one, the way we're going to combine it is we're going to say that the amusement park had a whole variety of rides, semicolon. All of us found something we enjoyed. Okay, so there we are. So we just learned how to combine two independent clauses to create a compound sentence by using a semicolon or by using a comma and a coordinating conjunction. Right, the next time we come back, we're gonna learn how to combine sentences, but by changing one of them into a subordinate clause. Okay, so if you're done with the notes, you can leave.
Please, I can't, please.
Say it again.
If you were good, I cannot see the last part what you write.
I can't see the last part. That's it. I don't have done under 5. There's only 5. Jasmine, please stay back.
Can you go back up to number 2, please?
Go back to number 2. Okay, all the way up to number 2. Sheesh. Okay.
I was out.
Yeah. Okay. Once you have finished taking down the notes, you can leave. Remember, Jasmine, I want to see you right after class. But the rest of you can leave if you're done. All right. Please make sure send in the class notes right when you're right before you right after you leave class, so that I can have it. Thank you, Deshaun. All right, so I'm going to stop sharing. And
1 second, I go on 5.
sorry.
I'm on number 5 right now.
Okay.
Okay.
All right, take care. Hello, Jasmine, are you here? Hello, Jasmine, are you here?
Pardon?
Hey, are you here? How you doing?
Good.
All right. I haven't been seeing notes from you. That's why I asked you to stay back.
Because it's the camera.
Uh-huh.
The camera is the one sending the picture every time I take. It is a error.
What? Ah, wow. That's on the camera inside the house?
No. No, sir.
Okay. Well, can you send me it using another phone? You have my number?
Okay. You could forward.
Yeah. What you want me to do? You send me my number, or you could get it from the other phone.
No, I go send it from WhatsApp off one
Okay.
to the next one.
Okay, excellent. Because I really want to see your notes, all right?
Okay.
All right, thank you.